The diagram shows 2 points A and B on a straight coastline, with A being 2.4 kilometers due north of B. A stationary ship at the point C on a bearing of 40 degrees and at a distance of 2 kilometers from B. Find the distance AC, giving your answer correct to 3 significant figures. Find the bearing of C from A. And find the shortest distance from the ship to the coastline. So I've got the question here then. So first of all, find AC, this distance here. We can use the cosine rule, can't we? So part 1 then. So here, the distance AC then is equal to B squared plus C squared. So AC squared is equal to 2.4 squared plus 2 squared minus 2BC. Cosine of the included angle. So what have we got then? Let's have a look. 2.4 squared plus 2 squared, which is 4, minus, and this is 4 times 2.4, 4.8, 9.6. So we can put 9.6 in if we want. Cos times cos of 40 degrees. Now we need to be in, let's go to mode, and we want to be in degrees mode, equals 2.41 to 3 significant figures, doesn't it? 2.41, and that was to 3 significant figures. Oh, so we need to square root that. So let's go back slightly, retrace our steps, and what was it from the calculator? 2.4059. So that tells us square root the answer then. So square root answer 1.5511, which equals to 3 significant figures 1.55 kilometers, and that's to 3 significant figures. Okay, that's part 1. Find the bearing of C from A. So here's A, there's north. So what's the bearing of C from A? Well, we need this angle here, don't we? So let's get this angle. Okay, so we know this distance now over the angle. Use the sine rule then, by part 2. Using the sine rule gives, so we've got AC over sine of 40 is equal to 2.2 over the sine of A. 2 over the sine of A. So move this up to this side and times sine A is equal to 2. Move the sine 40 up to be with a 2 at the same time. And divide by AC. So that tells us that A is equal to shift sine. So let's do that then. 2 times sine 40. So a shift sine of 2 times sine 40, 2 times sine 40 degrees, divided by the AC that we had, close the bracket for the shift sine, 55.976. degrees. So there's A. So the bearing would be north. This would be 55. So it's 180 minus the 55. Or it could be west. Yes, it could be west this much, east, south, couldn't it? So bearing is, we'll go west and then go 90 minus this, isn't it? So that'll be 34.02 degrees east, south. South. That would be the bearing. Or it could be north. Add 90 to this. 124.02 degrees. South, I suppose. Go around that way. No, it's not good. This is the one we want, I think. Because this might be ambiguous, but we go around clockwise. So I'm okay with this one, this bearing. So that's the bearing of C from A. Find the shortest distance to the coast. So we need to work out this distance here. So that was 55.976. So this angle here will be 90 minus 55, which will be 34.024. Or 90 minus that, and we know AC, so this distance here is AC cos. So part 3, the distance is equal to AC cosine this 34, wasn't it? And that was what we had in the answer. Okay, cancel that. So what have we got then? AC, which is 1.5511, times cos 34.02, close bracket, equals 1.2856. 1.2856, and so on, which equals 1.29 kilometers. So I've just looked at the solution here, and the bearing they want is the angle around from north. So add 90 to this and we get 124 degrees, 124 degrees. So rather than do that, we'll just write that as 124 degrees. Put it in properly. 124 degrees.